Sometimes when working with images, we would like to work on individual channels. Every color is the combination of red, green, and blue channel. In general, those channels are independent from one another. We can adjust the red channel and it doesn't influence the green and blue. However, it will alter the color. To separate the channels, we use the converter separate RGBA. When we drop it here, now we are looking at the black and white representation of the red channel of this image. That's the green channel, that's the blue channel, and this is the alpha channel. Alpha has nothing to do with colors, it's just a factor that will be used to composite this image with another images. But we will come back to alpha in one of the next episodes. Here we will be concentrating on R, G, and B. So say that for any reason we would like to adjust only the red channel of this image. Let's pass it through the color ramp. We can adjust this ramp, but we would like to use this ramp for the red channel of the image. So we have altered this, but now we would like to combine this all back to the image. So we use the converter combine RGBA. And as the red channel, we will use the changed red channel, but for the green and blue, we will use original green and blue channels. And that's the altered image, where we didn't touch the green and blue channels, but changed only the red channel. Sometimes it's our creative decision to treat channels separately, but in many cases it's a must, as some of the effects don't understand the image input type. Image is not the single value, but 4 values. But some effects, like let's say vector map value, has the gray dot as the input. If we connect the image to this and connect this to the viewer, you see that it made our image black and white. There are many uses of map value node, but I mostly use it to clamp the values by turning on the options use minimum or use maximum, or both. When I turn on the use minimum and set the value here, let's leave it at the value of 0, it will make every value that is lower than 0, 0. Every value greater than 0 will remain untouched. Use maximum, let's leave it at 1, every value greater than 1 will become 1, and all of the lower values will remain untouched. So use minimum of 0 and use maximum of 1 will clamp the values to the values between 0 and 1. So let's say that we want to do something like this to our image. Let's add the RGB curves and say we want to crush the blacks and adjust the gain like this. And let's take a look at the values of the darkest pixels. As you can see, some values are lower than 0. The visual range of every channel is between 0 and 1. So anything below 0 will be displayed as 0. So it may seem that it doesn't matter, but it does, because it's not that obvious that we will not want to change this image a little bit further by applying some other effects afterwards. Then here, those negative values will be taken into account. And in many cases it's not good. Here we see that blue channel exceeded 1, so it will be displayed as 1. But as well, if we do anything more with this image, this greater than 1 value will be calculated. Sometimes it's good to have the values greater than 1, but in most cases, negative values are nothing good. So we would definitely want to clamp this. And as we learned just a minute ago, map value node that we will be using for clamping doesn't understand the image input type, so we will separate RGBA, combine it back together, select both of them and hit F a couple of times. Now I will add vector map value. Let's turn on use minimum and use maximum, H to hide it, and we connect it here to the red channel. Let's duplicate it, connect it here, duplicate it, and connect it here. This way we have individually clamped the red, green, and blue channels. As you can see, visually nothing changed here. No matter if we take a look at the original image or at the clamped image, but original image has the values that exceed 1 or are lower than 0. And this one is clamped to values between 0 and 1 for all of the 3 channels. It's very likely that I will want to clamp many images in my project, so it's good to make a group out of it. Let's select all of those nodes, hit Ctrl G, tab to expand it, let's call it clamp, make a fake user, and let's also create 2 more versions of this group. Let's click this 2, and let's call this one clamp black, and I will change those nodes not to use maximum but use minimum, and do the same for all of them. So this is clamp black. Let's make a fake user of it, make a copy, and this will be clamp white. And for this one, I will not use minimum but use maximum. Do the same for all of those nodes. Tab to collapse it. Let's hit Ctrl X to delete it, leaving the connection. So this is the original image with negative and greater than 1 values. If we now want to clamp only the blacks, group, clamp black, drop it here, and I'm done. Blacks are clamped, but values greater than 1 remained untouched. Let's delete it. Add clamp white. Now only the whites are clamped and negative values remained untouched. Or we can change it to use, instead of clamp white, let's first make a fake user of it. Now let's change it to clamp. So this group clamps both black and white. Okay, so now we know how to separate RGB channels and treat them separately. But RGB is not the only system that exists. There are other systems that are used to describe the colors. Let's go back a few decades and imagine that we are living in the times where only black and white television exists. Let's convert our image to black and white. Somebody invented color television, so now we are able to watch such images. But we had a problem of compatibility of the signal with both color TV sets and black and white TV sets. There was a need to invent the system that could be decoded by both kinds of TV sets. So we have the black and white signal and some other signal that describes the colors, that is understood by color TV sets but ignored by black and white TV sets. Such system needed to be invented because it was impossible just to say to all of the people all around the world to throw away their old TV sets and buy new ones. So the system called YUV has been invented. So we have, let's add converter separate YUVA, and this is Y, which means the luminance, so it's just a black and white signal, and we have 2 more components, U component and V component. Those channels pass the chrominance, meaning the color information. I will not go much into details of what U means and what V means. The combination of those 2 signals simply give us the color information. So this node converts the RGB information to YUV and gives us the access to those individual channels. So we have RGB, here we have YUV, and we can also use another system like this one. This is very similar to YUV, and sometimes those systems are confused. We can see that many times people say YUV, where what they really mean is this system, YCBCR. Here in this node, as you can see, we have 3 options. Those are different systems. Like this one, for example, 709, is used in HD television. This JPEG, computer graphics, and this standard definition television. This system is very similar to this one. Let's connect it to the image, and when we use the JPEG option here and take a look at the Y, meaning the luminance, you see that this one is exactly the same as Y from this system. But if we change the JPEG to one of those two, you see that the luminance changed, and here it's a little bit different. This channel, CB, is often described as the difference between blue and green, and this one is the difference between red and green. And if we change those options, you can see that those values also change a bit. So that's another system. YUV is analog, this is digital, and we can also have the access to another system, which is HSV, and this is nothing more than hue, saturation, and value. When we add the input color, RGB, you see here we can use RGB and we can use HSV. And this is exactly the same as this. Right now we are looking at the value. Value in everyday language is the brightness, right? But let's take a look here. This is the luminance. It's also the brightness, but you can see that it's different than this one. This is value, and this is luminance. This is luminance using the system YCBCR with the JPEG option, but this is luminance when we use this system, and this is the luminance when we use another system. And that's the luminance in the YUV system. By the way, this is exactly the same as the luminance when the JPEG is used here. There is yet another system that is very often used, but we don't have the access here in Blender to this system. It's very similar to hue saturation value, and it's called HLS for hue lightness saturation. We don't have direct access to the lightness, but in one of the next episodes I will show you the differences between brightness, luminance, lightness, value, and describe what they mean and how we can make use of them. Okay, so we have many systems and we have many possibilities to separate our image. And there may be various applications of this, like separately treating RGB channels, or change the luminance without touching the chroma, or exactly opposite, treat the chrominance without changing the luminance. We may also use this for keying. When we take a look at the original image and say we want to key out certain color, we may take a look at the individual channels of different systems and try to find one channel, combine it with another channel, maybe one channel of one system with another channel of the different system, and this way we can find the best combination that will separate certain areas of the image. And I will show you some examples in one of the next episodes where we will be talking about some advanced keying techniques. But for this part, it would be all.